Good evening once again, ladies and gentlemen. The chairman, the organizers of the Second International Conference on Survival and Sustainability. Still want to thank each and every one of you for this opportunity to present to you and investigation into maximum power for tracking photovoltaic system. My name is Eze McDominic, and I'd like to bring to attention that this work has been organized by Dr. Lida McDominic Eze and Mr. Engin. The order of the presentation is as follows. We'll take the introduction, objective, the test results, discussion, and then the conclusion. The introduction, due to lack of non-renewable energy sources, PV systems are one of the best alternatives. The global installed capacity of solar power is more than 100 gigawatts, and that makes it the biggest source of energy after hydro and wind. The operating cost of a PV is nearly negligible, as there is no fuel use, and the maintenance cost is low, as there's no moving part, there's no mechanical part involved, and the solar panel lifespan ranges between the 30 years span, and the PV system may be standalone off-grid system and may be connected to utility grid depending on the application and the economics or the system which it is being utilized. The objective of this project is for better performance. We want to target a better performance of the PV system, and also to collect more solar radiation, and also to attach a solar panel with sensor and motor that guarantee facing the sun during the day hour. Then we will do a comparison between the power achievement in the case PV, that is the one that is fixed as a station, and also the one that is oriented a self-adjustable system. Then also develop a MATLAB program to control the PV panel orientation in order to collect maximum solar radiation by tracking the sun path. Experimental is done using a pyranometer. Was tabulated temperature against time on this date on the 9th and 12th, 2017, and on the 10th of 2017 of December. It was a 2 days test day, and the data was collected, and also the graph is being represented there. The experiments were carried out at Nearest Solar Lab for 2 days, and the temperature value were measured for each hour starting from 6:30 a.m. until 8:30 p.m. as shown in the graph. The graph is a representation of the experiment that was conducted at the lab. And also some other data was also collected from the meteorological office, which run through the October, November, December within that month, and it was also represented in a graph. It can be seen that the radiation level at the highest at highest in December, and gradually falls down during the end of the month. The PV panel was oriented between the south direction face. It was a south face. It was a one face. That this one is the fixed orientation, and also the slope was set at an angle of 32 degrees. Both current and voltage readings were recorded hourly on the 9th and also on the 10th December 2017 using a voltmeter. Between the time of 6 a.m. and 5 p.m. the power value were calculated for voltage and current, and the readings were also taken hourly. The maximum power also achieved from the tabulated value to be at 12 and to 1 p.m. where the sun is at maximum or at its peak. The graph was was created, and also the graph of power, voltage, and current was tabulated, and also according to those days that was calculated. The implementation of a MATLAB program by adding an IC chip connected to the sensor that senses the maximum radiation from the sun, the motor can be rotated accordingly to achieve maximum power. Entering the value of the geographical latitude of the exact place, the time, and the date as input value to the MATLAB program, and the output will be the azimuth and the elevation location of the sun in a degree. Hence, the solar tracking system could be seen in the next slide. We could see there is a mechanism that allow the device to orientate when the sun reorientates itself every 10 minutes. The system is set up to track the sun so that it could achieve maximum power. The MATLAB output and input and output description. The input description was taking the coordinated universal time, the site latitude in degree, the site longitude in degree, and also the altitude of the site above sea level in kilometer. And also that for the output was the azimuth location of the sun in degrees and the elevation location of the sun also in degrees. The implementation of the MATLAB program was done, and then in conclusion, this project was used. We used a solar panel, polycrystalline solar module, the TRU10P, and got the experimental result for both the current, the voltage, and also calculated the power along 2 days acting. And this value in the graph was also represented in the graph. The radiation value for the last 3 months was also determined using the data collected from the meteorological office. And we also simulate the tracking solar system by using a MATLAB program to adjust the angle to achieve maximum power and performance. And based on the result obtained, we conclude that the MATLAB solution for a solar tracking system offers several advantages concerning the movement command of the PV panel. Thank you very much.
This was a very interesting presentation. Any questions? Go ahead.
I was wondering, was there any specific reason that you choose the December days?
Was there any?
The specific reason that you choose the December days, these days in December, to measure and choose the data to check or to test your...
No, there wasn't, as we could run for a longer period of time. But because we at that point, we had a limited, I think the arrangement, the lab arrangement was, we had a limited day, so we only tested the project for just 2 days. There was no specific reason attached. We could run it for months.
Is like, I don't know, is it the right time? Because solar, like summertime wouldn't be great.
Yeah, it was a student project. Yeah, it was a student project. So we are trying to. It was at that time we conducted the experimentation.
At that time, and then he left. The thing is, I think, good point. I mean, it should be interesting to see the changes during summertime as well. We calculated the solar energy potential of North Cyprus, and we found that it was enough to supply all water needs from either the sea or brackish water for a voltaic panel of approximately 2 kilometers square. So you have so much energy that is wasted in North Cyprus.
Yes. Thank you very much.
Yes.